Hello, 8th graders. You need to take notes on Chapter 7. We'll be going over pretty much 3 different ways of solving linear equations that have 2 variables in there. So, the first technique that you can use is by graphing and checking. So, the rules for graphing and checking is first you write each equation in a form that is easiest to graph. Usually this is in our slope-intercept form of y equals mx plus b. You would then graph both equations in the same coordinate plane and then estimate the coordinate of the point of intersection. Then you go through and you check the coordinates algebraically by substituting into each equation of the original linear system. So, for example, if we have solved the linear system graphically and checked the solution algebraically, if they give us 2 different formulas, so 3x plus y equals 11 and x minus 2y equals 6. You first put each one of them into slope-intercept form in this case, and 3x plus y equals 11 you see is y equals negative 3x plus 11. This gives you your y-intercept of 11 and your slope of negative 3, and you would graph that. Then you would do that to it's the same thing to the other equation. So x minus 2y equals 6. If we put that into slope-intercept form, you get y equals 1/2 x minus 3. So you know that your y-intercept is negative 3 and your slope is 1/2, and you graph that. So if we were to graph that, you can see right here both of our lines graphed, and the point of intersection is 4, negative 1. So then you would go back and you would plug in 4, negative 1 into each equation and see if it is a solution. So if you go through, I have 3x plus y equals 11. Substitute in 4 for x, negative 1 for y, and you can see that 11 equals 11. That is a true statement. Same thing for x minus 2y equals 6. You plug in 4 for x and negative 1 for 2. And you get 6 equals 6. So since these are both true statements, you know that 4, negative 1 is the solution of the linear system. So that's one way of doing it. The other way of doing it is you go by substitution. So first you solve one of the equations for one of its variables. Then you substitute the expression from step 1 into the other equation and solve for the other variable. Third step is you substitute the value from step 2 into the revised equation from step 1 and solve. Then you check the solution in each of the original equations. So we are going to use the exact same formula so you can see that all 3 of these work and get the same answer. So first we have 3x plus y equals 11 and x minus 2y equals negative 2. I'm going to, since I think it's going to be easier to solve for x in equation 2, you can choose whichever variable in either equation, whichever one is easiest. So I chose equation 2 to solve for x. So I find out that x equals 2y plus 6. Now I substitute in 2y plus 6 for x in the first equation. So I have 3 times, you can see here instead of x I put 2y plus 6 plus y equals 11. Then I distribute and I get 6y plus 18 plus y equals 11. I combine like terms, 7y plus 18 equals 11. And I isolate and I get 7y equals negative 7. Divide by 7 and I get y equals negative 1. Now you go through and you substitute in negative 1 for y in my revised equation 2. So x equals 2y plus 6. I substitute in negative 1 for y and I get x equals 4. And so you can see 4 minus 1, or 4 negative 1 is a solution. You would check that by substituting it in. I'm not going to resubstitute it in because I did the very first time, and you can see that they do come up to a true value, and that is an answer to the solution. Now our third way is It's called linear combinations. And to me, I think of it more of an elimination type of process, but you're actually combining some of these things. So you arrange the equations with like terms in columns. Then you multiply one or both equations by a number to obtain coefficients that are opposite for one of the variables. You add the equations from step 2. Combining like terms will eliminate one of the variables, and then you solve for the remaining variable. And then you substitute the value obtained in step 3 into either one of the original equations and solve for the other variable and check the solution. So again, we're going to use the same equations. So you can see 3x plus y equals 11 and x minus 2y equals 6. Well, I see I already have a negative 2y, and I just need to get a positive 2y so that I can eliminate the y variables in this equation. So I multiply both sides of the first equation by 2, and I get 6x plus 2y equals 22, and then you add your other equation of x minus 2y equals 6. So you have 6x plus x equals 7x, 2y plus a negative 2y cancels out to 0, and then 22 plus 6 is 28. Isolate your x, and you get x equals 4. Then you substitute 4 into either one of the original equations, and you solve for y. So here I plugged in 3 times 4 plus y equals 11. 12 plus y equals 11. Subtract your 12 and you get y equals negative 1. So again, you can see for the third time we've proven this in a different way, that the 4, negative 1 is a solution to both of those equations. And that is the lesson. Please come with questions and have a great weekend.